Hello everyone, welcome back to the next video. In today's video I will show you how to do face mesh detection using MLKIt in native Android application. I've already made a video on how to do it using MediaPipe, so if you are interested you can watch that video. So firstly I'll show you guys the output. So I'll just run my application, and once I run my application it presents me with a button called pick image, and if I click on pick image I can pick any image which has a face in it. So if I pick this image, this, and as you can see it is able to detect my face, as well as it is able to draw a bounding box as well. I can select some other image as well. So as you can see this is the output. Now let's see how to do this via code. So first what you will have to do is you will have to go to the MLKIt documentation, and I have copied a lot of code from this sample app, so it's better you download this sample app locally, because I have copied a lot of code from that. And here you will have also need this dependency. So just copy this dependency, go to your build.gradle file, and here I have added it. Okay, and if I will show you, so this is a new thing in Android Studio Iguana. I will show you the libs.version, and here you can see I have added the face mesh detection over here, and this is how you reference it. Okay, directly referencing this in your build.gradle is an old way of doing things, but yeah, you can still do it, but this is a new way. And I have also added this Gova Android dependency, this one, sorry, and I have also added the preferences KT dependency, and let me check which one, and coil. Okay, so I have also added this. So for coil you can add this. Okay, next for preferences Kotlin extension you can add this, and for Gava you can add this. Next once you add all this dependency, so libs.gova is required for preconditions which is present inside this graphic overlay. Preferences Kotlin extension is we need to add, because otherwise if you use the normal imports without this build.gradle file, without this dependency, sorry, then you might get a lot of deprecation warnings. And coil is used for loading image from a URI or bitmap inside an image view. Once you add that, just click on sync now. Then if you go to my activity underscore main, here I have taken one button, then I have taken one image view which occupies the entire width, remaining width and height of our screen, and this graphic overlay occupies the entire width and height of our image view. So whatever is our image view. Now from where do I get this graphic overlay? So for this you will have to create this. Now I have just copy pasted this code from documentation. So basically the face mesh which is been drawn on the face, that's what it does. So I will just simply scroll through this. Again, it is a Java class. If you want you can convert it to Kotlin, but yeah, so I will slowly scroll through this. There is a lot of comments, that's why it is looking a little big, and also there are some unnecessary methods which I'm not using. So if you want you can remove those as well. Just be careful with this. All right, okay, next we also need this bitmap utils file to rotate our bitmap or to get a bitmap from our content URI. Again, I have copied this file from the documentation itself, so if you want you can just copy paste it. So yeah, next I have created this camera image graphic class. Again, I'm not really sure if you are using this, but I was facing a lot of issues, so I had to involve this class as well. Again, this has been copied from docs. Then there is this face mesh detector process which extends this vision processor base. I'll come back to that in a bit. And here it takes a list of face mesh, and here we are creating our face mesh detector. We are creating options for it, and here the options which we are setting is bounding box only. Then detector is face mesh detection dot get client options builder dot build, and here we have overridden some methods like detector.stop, detector.process. On success we are adding it to our graphic overlay, and on failure I'm just logging it to the console and some companion object as well. Next is the face mesh graphic. Again, this is like I have copied it from the documentation, sorry, won't be able to explain it, but yeah, it just like drawing on on your face, like whatever image you have picked. Okay, next is graphic overlay, which I have already shown you. Next is inference infographic. Again, this I have copied it from the docs itself. Okay, next I'll come back to main activity in a bit, and this is our preference util to, because we are storing some data inside shared preferences. So yeah, this is how it is. Then there is scope executor, like we need to do all this stuff on a background thread, we don't want to do it on the main thread. So again, be careful, like these are Java classes. Okay, next I have defined an interface. So interface vision image processor, which takes a process bitmap of bitmap and graphic overlay. Then this vision processor base, which is again a Kotlin class. So this is, I have defined this an abstract class. Again, copied it from the docs, even I am not really sure what exactly is happening over here. Okay, once you have copied all this, next we will go back to main activity, and here you can see I have created variables for our button, image view and graphic overlay, as well as our vision image processor. Next I'll minimize this for now. Here we are initializing our image processor, our button, image view and graphic overlay, and on button click listener we are just launching our get content.launch. We are passing the image mime type, and once the image is once the user selects an image, we get a URI. From that URI we convert it to bitmap, then we clear our graphic overlay if any, then we set the image bitmap to our image view. And here if the image so here you can see, if you want you can use coil as well, but I'm not using coil in this case. So if you have added coil inside your build.gradle, you can remove it, but if you want to use coil you can use it as well. Then here if the image processor is not equal to null, then I'm just setting the image width, height, as well as just checking with whether the width and height are not equal to null, and then calling the set image source info on or a graphic overlay, and then we pass our graphic overlay as well as image bitmap to the process bitmap method of image processor. Yeah, that's it. Thank you for watching. Bye.